Okay, welcome back. So we're going to move on to double angle identities. Let's write that on there. So these again are all on your formula sheet. So double angle identities. All right. So you don't have to memorize these, but it is helpful to kind of understand what they are. So you're kind of looking for patterns. For sine, there's only one. So you don't have to worry too much. But if we look at cosine, and sorry, where the double angle comes from, if you look inside, whatever our angle is, it is the same one, just multiplied by 2, so therefore double. Now for sine, there's only one identity, but for cosine, we have an option where we have cosine squared, sine squared, 2 cosine squared x minus 1. We have cosine 2x equals 1 minus 2 sine squared. So you have to look in your expression, in your equation, which one of these would be the most useful. And we'll go over some examples. And then for tan, when it's a double angle, there's only one choice. And yes, I figured out how to scroll down and extend the page. So we're doing good. We're doing better. All right, so first question, write each expression as a single trig function. So when I look at this, I'm going to my formula sheet, and I notice that these angles are actually the same. So angle A and angle B is what we were talking about before, but now it's actually just the same angle. So that tells me, hey, that's a double angle. So I go and look at my formula sheet. Well, which one has sine and cosine being multiplied? Well, that's our sine identity. And so it's going to become sine 2 times whatever our angle is. And again, our angle is the same here. So it's going to be pi over 4. Now we should simplify that as much as possible. So that cancels out to become 2 and 1. So you just get sine pi over 2. Oh, wow. That's way easier than what we were doing before. And that's it. The question's done. It's written as a single trig function. So moving on to another one. This one looks a lot worse. Same question, though. I'm looking on my formula sheet. As soon as I see this, single trig function, there's not a lot of options here. So we only have the one. Things I am looking for, though, is that it is actually squared. And then we have a subtraction here, and we have a times 2 right there. So those are some things that are keying me off that, hey, this might be actually a double angle. So we go and look on our formula sheet. And that squared here is coming from the fact that it's actually 76 happening twice. So I go and look in that formula sheet. I see, oh, this is actually 2 times whatever our angle is. So in this case, our angle is 76 degrees. And so therefore, tan is equal to sort of 152 degrees. Now we have, it doesn't ask us to evaluate it, so it just says to write as a single trig function. Now on a diploma, I'm going to guess that it's going to say determine. Okay, I would be looking for the word determine, so they would expect you to show some kind of work like what was shown here. So write each expression as a single trig function. So we have one more very similar question. So some things that are just right away throwing me off, or that I'm looking at, we have a square right here. So that tells me that this angle pi over 6 is actually happening twice. So I go and look in that formula sheet. There is 3 cosine identities to pick from. And sure enough, it does match one of them. So then I'm looking at, well, cosine. Now double my angle. Be careful. X is also part of my angle here. So this is double 2x pi over 6. Now with that then, we can actually do some simplification here. Make sure I pick one that's the right size. So this will become 3. This will become 1. So this is actually cos x pi over 3. Question's done.